We're going to talk about types. We're going to talk about what they're for. We're going to talk about which types that are built into the language are most useful. We're going to talk about the relationship between types, variables, values, and expressions. So let's start with a definition of type. Well, we could go to the specification. This is the specification for the C# language. This was the C# 4 specification. As you can see, it is 800 pages long, over 800 pages long now. And it uses the word type thousands and thousands of times, and it never once defines it. Right? So why is that? The reason is that it's actually quite tricky to give a formal definition of what a type is. It's so tricky, in fact, that the language just assumes that the language specification just assumes that you already know what it is, and it just kind of goes with it. Right? And if we were trying to give a proper formal definition, we would need a lot of computer science background for it. So let's just say that a type is a set of values that have something in common. So for example, all of the integers are a type. All of the strings are a type. Right? The rules for how different types interact with each other in a programming language is called the type system of the programming language. And the language whose type system enforces strict rules is said to be type safe. So rather than try to get a formal definition of what a type is, I would rather just say the purpose of a type is it helps you understand your program, and it helps you automatically find bugs in your programs by preventing errors that would violate type safety. Right? Every value in the C# programming language, with a few small exceptions that we might get into later in this course, has a type. In fact, every value has more than one type, although understanding why that is would require us to get into some of the details of object-oriented programming that I'm not going to get into in this course. Now, there's a bunch of different rules in different languages for type systems that kind of impact how aggressive those type systems are. Right? There's a spectrum. Right? So on the one hand, we have languages like C# that are fairly aggressive about saying there's an error in this program. It looks like the types don't all check out the way you would expect them to. There are even more aggressive languages than C#. Languages like Haskell have more rigid type systems. And there are languages that have less rigid type systems. Visual Basic has a slightly less rigid type system than C#. JavaScript has an even less rigid type system, and so on. People often call points on this spectrum either strongly typed or weakly typed. I try to avoid that because if you look in Wikipedia, if you look on the page about type systems, it will list 11 different definitions for what strong typing means, and many of them contradict each other. It's used so much that if you're having a conversation with somebody and you just say, I like strongly typed languages, odds are pretty good they're not going to know what you're talking about, because the definition that you have in your head and the definition they have in their head are highly likely to be different. Right? So I always try to avoid strongly typed. I would say that C# is a statically typed language, not a strongly typed language. And by statically typed, I mean the type information is analyzed by the compiler or by the IDE, by Visual Studio, and can tell you before the program even runs, it looks like you have a type error in this program. So they say that it's statically typed rather than a dynamically typed language is one where the types are known only at runtime. Right. So let's look at some examples of some type errors. We'll start up Visual Studio here, and I've tried to divide the string ABC by the number 1, 2, 3. Now, you saw in the previous video that we could add these together no problem. Right? We could say ABC plus 1, 2, 3. It would convert the 1, 2, 3 to a string, concatenate them together. The slash is the division operator, and we'll talk about some of the other operators for doing mathematics in a later video. Though it is legal to add strings and numbers, it is not legal to divide strings and numbers. The type system will not allow you to do that. And if you see we've got a red squiggle here, and if we hover over it, it says operator slash cannot be applied to operands of type string and int. Okay. I mentioned in a previous video that the integer type is called int in C#. And again, this is for historical reasons. Same reason why it's var and not variable. It's also int and not integer. Please don't use this as a model. Right? This is not a good practice for creating new code. I always try to spell out words so that they are fully understandable words and not abbreviations. All right. So what are some other type errors we could make? Let's comment that out. We might also say, let's suppose that we have a variable name, and we can say that my name is Eric. All right, this is something that we haven't seen before. We can assign a value of string type to a variable. Before, we've only been assigning integers to variables. But this is perfectly sensible. Again, we get this green squiggle under here saying, oh, you've created this variable, but you haven't used it in any way. Well, we can fix that. Let's say that we have another variable, var number is 2. And then what if we say name equals number? What happens? Well, now we get another red squiggly. And what does this one say? This one says, cannot implicitly convert type int to string. Right? So what's going on here? The name of this variable is name. Its type is string. Right? You can see it says here that this is a local variable. Its type is string. Its name is name. This variable, its type is int, and its name is number. The C# language says you are trying to assign a value, which is an integer, to a variable, which is a string, and that's not legal. All right? We've seen string is the type of string values. Int is the type of integer numeric values. All right. Now, if we go back to the code, something we can do here, you might think that this is maybe a little bit unclear, right? That this variable name is actually a string. We can replace this var with string, right? And now it becomes super clear. OK, this is a variable. Its type is string. Its name is name. Its value is Eric. And we can do the same thing here. We can replace this with int, right? And now it becomes very clear what's going on here, right? Now it's totally clear that this guy is a string. This guy is an integer. We're trying to assign an integer to a variable that's of type string. Now, I said earlier that there are other kinds of values that we might want to manipulate. You know, we might want to know, you know, what are the masses of these bananas, or we might want to know, you know, how fast they're moving, or whatever, right? We might want to know how much they cost. So there's a bunch of different types in C#. Let's take a look at some more of those. So I have this other copy of Visual Studio here where I've created a bunch of different variables of different types. Right? So I have int, which is integer. We've seen this plenty of times before. And we have an integer literal here that's 2. Right? We have double. Right? I have a variable called mass of banana of type double, and it is 65.3. I suppose it's 65.3 grams, or whatever our unit of mass is. Right? We have a variable of type decimal, the price of the banana, maybe it's 85 cents. And you'll notice here that this literal, it looks like the decimal, it looks like the double literal, but it is got an M at the end. Right? The M is for money. You might wonder, why is double called double? That's kind of a strange way to say this is a fractional number. This is, again, for historical reasons. There was a previously used floating point arithmetic type used in many CPUs. It exists in C#. It's called float, which kind of makes sense. The double type is a floating point type that takes up exactly twice as much memory as the normal floating point type, and so it was called double. That's maybe not a great reason to give something a name, you know, based on the characteristics of how large an amount of storage it takes compared to something else, but the name stuck, right? And the M in a decimal literal stands for money, and we're going to talk in more detail later on about why it is that there's a difference between physical quantities that go in variables of type double and fiduciary qualities, currency properties that go into variables of type decimal. We saw we can also have variables of type string that contain text. And there's a bunch of other ones. There is a variable called, there's a variable type called char. Now this is another unfortunate abbreviation. Char is, of course, spelled as though it were pronounced char, but character does not begin with the syllable char. So some people actually pronounce this car or care. Most people just say char. It is unfortunate that it's char at all instead of character. And we're going to be spending quite a bit of time in later videos talking about Boolean variables. Boolean values and the variables that store them can only have two values, true and false, and they're used to implement Boolean logic. We will talk about all of these in more detail in later videos. There's a whole bunch of built-in types that we're not going to talk about past this slide in this series. They are byte, sbyte, short, ushort, int, uint, long, ulong, float, and object. I already mentioned float as being the single precision floating point type. Most of the rest of these are integers of various different sizes. And object is the sort of the root type of C#. And it's used in object-oriented programming. That's why object-oriented programming is called object-oriented programming. Let's sum up. We're going to say that a type is a set of values. That's maybe not the best possible computer sciencey definition, but we're going to go with it. We know that C#'s type system enforces type safety when we're evaluating arithmetic, when we're assigning values to variables, and so on. And we've seen that there are types int, double, decimal, string, char, and bool. And that all of these have literal expressions. We saw that double, we could say 65.3. We saw with decimal, we could say 0.85 m. We've seen string literals. We saw a character literal. We saw the letter B. And we saw the Boolean literal false.